and good afternoon to some of you. Thank you for joining us today. Thank you for taking the time to join us for today's webinar. From incident to recovery, responding safely to lithium battery fires. My name is Sam Schabowski, and I'm a part of FACS's marketing team. And this is actually a first for us for these webinars. We've been doing these for a couple years now, and this is actually the biggest panel size that we got from our experts presenting all together on one single webinar. It's a great opportunity to bring together so much expertise for one discussion, and we're excited to share their insights with you today. To kick things off, I'd like to introduce each of our presenters so you have a better sense of their expertise and experience. First, we have Michelle Rosales. Michelle is a Director of Environmental Health Services at FACS and a certified industrial hygienist. With more than 20 years of experience leading environmental health and industrial hygiene investigations throughout California and across the US. Michelle specializes in wildfire and structure fire impact assessments, occupational exposure evaluations, and indoor environmental quality investigations. She has managed hundreds of complex projects involving physical, chemical, and biological hazards, helping organizations safely assess, remediate, and recover from environmental incidents while navigating OSHA, EPA, and other regulatory requirements. A nationally recognized expert on wildfire smoke and its effects on buildings, occupants, and workers. Michelle is the primary author of the AIHA Technical Guide for Wildfire Impact Assessments for the OEHS professional. Next, we have Kristy Thornton. Kristy, also a Director of Environmental Health Services. She brings over 10 years of industrial hygiene and environmental health experience to the discussion on lithium battery safety today. As a certified occupational hygienist, she helps organizations identify, evaluate, and mitigate complex chemical and physical hazards from thermal runaway off-gassing to post-incident environmental recovery. Kristy has partnered with clients across construction, manufacturing, municipality infrastructure, and emergency remediation to build practical science-based safety protocols. An active member of the AIHA and AIOH, she is passionate about turning complex environmental and occupational health science into clear, real-world strategies that keep workers and facilities safe. Third on our list today is John Paul Angulo, or JP. He is a Senior Project Manager here at FACS with experience across a broad range of environmental hygiene and occupational safety disciplines, including exposure assessments, safety audits, and regulatory compliance and written program development. Before FACS, JP worked in the aerospace and defense industry, where he supported complex research development, manufacturing, assembly, production, and testing operations. In these roles, he helped identify risks throughout the full life cycle of advanced technologies. In addition to traditional industrial hygiene services, JP has specialized experience in laser safety, non-iodizing radiation, and electromagnetic field assessments. And he continues to expand these capabilities as part of FACS's consulting services. JP is also a board member of his local AIHA, who strives to combine technical expertise with practical client-focused solutions that help organizations effectively manage workplace health and safety risks. And last but certainly not least, we have Michael Kopaigorodsky, a Senior Project Manager also at FACS, who is a registered environmental health specialist and a certified hazardous materials manager. With more than 20 years of experience managing comprehensive environmental health and safety programs across consulting, industry, academia, research, and the public sector. He specializes in helping organizations navigate complex environmental regulations and develop practical, sustainable solutions for environmental compliance challenges. Michael's areas of expertise include hazardous materials and hazardous waste management, emergency response planning, industrial hygiene, and laboratory safety, air quality compliance, environmental permitting, and regulatory compliance. He has extensive experience developing and implementing environmental health and safety programs that help organizations help their employees maintain regulatory compliance and effectively manage environmental risks. So after that mouthful, before I hand it off to the team though, just a few housekeeping items and First, I'd like to quickly cover a few components of our GoToWebinar platform. Everyone is in listen-only mode, and so we can't hear or see you, but it does not mean we cannot communicate with you. As you think of questions, have any concerns, anything like that throughout the presentation, feel free to see the question box in the top right there. Feel free to type something in there, and myself or someone on the team will be able to take a look at those questions and hopefully follow up at the end in our Q&A session. Second, and this is just a quick, I'll remind you at the end too, but we will be sending out a copy of the slides as well as the recording of this presentation, so you can take a look at it later or share with other with other teammates. And with that, I'll give it off to the team.
Thank you, Sam. I appreciate that. Good afternoon, everyone, and welcome to today's FACTS webinar on lithium battery fires. As you see, we have a lot to cover in a very short amount of time, so I'll try to get started on that. Lithium batteries, they are now a very essential part of our modern life. They power devices such as our smartphones, the laptop I'm using right now, right to the electric vehicles, and then they have these large energy storage systems. So the lithium battery fires are somewhat of a new emerging issue, and we're identifying some of the very health and safety aspects associated with it. So we're glad to speak today to kind of go over that with you. And again, although they're wonderful, they do provide, if they are not stored correctly or there's issues, they can lead to thermal runaway, leading to fires, explosions, and release hazardous chemicals and particulates. So we're going to go over some of the just 101, what it means, what is a lithium battery fire? How is it different than a typical maybe structure fire? The health and safety hazards and aspects associated with that, remediation, employee health and safety. So when we're remediating it, first responders, that type of situation, as well as the waste characterization, disposal, and then what we always want, right, is not to have the issue, some of the prevention and best practices associated with storing of these items. So again, as I said, we are going to be covering a lot. When we talk about lithium battery fires, we can talk about small scale ones where maybe someone's cell phone or right here an electric scooter on the upper right caught fire, or we can even discuss some of these larger scale events. On the top left is the Moss Landing event. I'm not sure if people are aware of it, but it was in early January 2025, where in Moss Landing, which is located in a rural area of Monterey County, there is a storage facility, which was considered and probably still is the world's largest lithium ion battery storage. And there was a fire event. I think they said 55% of the batteries were damaged by the fire and just caused an increase of toxic smoke to be emitted from the facility. And then what you'll learn when we talk a little bit more about lithium battery fires is that you have a fire event, you think you're done with it, then it reignites. And so that's what happened here at Moss Landing as well. So it reignited a month later after the event occurred. So there are lots of different types of lithium ion batteries out there. I'm just going to go over a couple of these. Each one serves its own purpose, as well as potential hazards associated with it. So we have the lithium iron phosphate, which is known for the stationary energy and electric vehicles. We have the LCO, which is the lithium cobalt oxide, which delivers a high energy density but has lower power output. It's commonly used in your smartphones and your laptops. So all of these different ones have different purposes and also create their own potential smoke contaminants, right? So we're dealing with different metals. And so when we're talking about characterization or evaluation of employee health and safety, we kind of want to know a little bit of this information so it helps dictate kind of what our sampling strategy may be. So, alone, just a battery is not a hazard, right? There has to be a reason where there's potential exposures. And that's when you have the fire event. So some of the common causes of lithium ion battery fires are physical damage. So if someone punctured, crushed, deformed it, extreme temperatures are not stored in a cool area. So direct sun or heat may degrade the batteries, causing maybe a thermal runaway or smoke or fire event from occurring, overcharging, faulty charging. So that's a lot of times when we're talking about these residential properties where there's a fire event, usually you're getting situation number 2 here. But again, improper storage. So there's a lot of different causes that can lead to a lithium ion battery. And generally, again, it's a heat buildup that leads to thermal runaway, to smoke, and to a fire event. So what are we being exposed to, right? Well, let's just go back a little bit before talking about lithium ion batteries. But typically when we're talking about exposures to smoke, we know that's a broad term, right? Because smoke is a mixture of some solids, liquids, gases, vapors, particulates, you name it, a bunch, colloidal mix of stuff that's created specifically for that fire event. And so it's dependent on the fuel type, the oxygen supply, the combustion temperature. This is all going to help dictate what is the smoke is composed of, as well as other environmental atmospheric conditions. So you may have something created down at the level of the fire, but once it kind of moves throughout the atmosphere and mixes with other gases and vapors and just the air, it may create new compounds. So it's really hard to characterize, right, when we're talking about smoke. But when we're talking about lithium ion batteries, some of the common smoke composition you'll get and some of the contaminants of concern that we will typically look for is the more of the acidic vapors, so the hydrogen fluoride, right? You usually hear that a lot when we talk about lithium ion batteries and exposures. Hydrogen chloride, sulfur dioxides, we know we're going to get asphyxiants, which is pretty much common for all fires. The carbon monoxide, carbon dioxide, other combustible vapors, and then again, those metallic particulates. So remember when a few slides back, we talked about all the different types of lithium ion batteries there are. And so one, obviously the lithium, but we can get the cobalts and nickels, manganese, and calcium. It's just highly dependent on, again, what was the fuel source, being the battery itself, and then what it may potentially have burned as well. And I'm going to hand this off to Kristy to talk a little bit more about battery fires.
Yeah, thanks, Michelle. So to kind of set the stage, as Michelle mentioned, lithium battery fires are everywhere. They're occurring at small scale, large scale, and the media response to that is slightly sensationalized in some instances. So we really want to kind of examine that public perception versus the technical reality when it comes to these type of fires. And when there's a lithium battery fire, it hits the news, the media often kind of frames it as an uncontrolled kind of disaster, causing weeks of panic and a lot of community and environmental response. And these fires are undeniably, they're complex, they can be dangerous, but there is a lot of data-backed industrial hygiene that demonstrates that some of those offsite risks really can be safely contained and controlled if you have a good plan in place. These multi-day operations at these larger grid scale sites, and they kind of have that controlled thermal cooling, if you can handle the stranded energy, and we'll go into that a little later, rather than kind of the uncontrolled blaze like you can see in the picture here. So our role really as the EH&S professionals is to kind of replace that alarmism with a lot of data, rigorous air sampling, exposure monitoring, water testing, and really be transparent with community communication and trying to keep people as informed as possible. So when we're looking at lithium batteries, as Michelle alluded to, kind of the big thing with that is the thermal runaway. The first stage is really the defensive strategy. If we're talking about a large scale facility like a battery energy storage facility, or even a building where you have a set area where a number of lithium batteries are stored. In traditional firefighting, the goal is often to kind of search and rescue, then suppression. But for a lithium battery or a large scale fire involving lithium ion, the paradigm kind of fails and it shifts. So we want to really emphasize, in this instance, it's really not about putting the fire out sometimes, because lithium will just continue to reignite and have that thermal runaway. It's about removing yourself, preserving life safety, maintaining kind of that perimeter, and preventing exposure to those toxic off gases that we discussed earlier in the slides that Michelle mentioned. The second phase really is that the incipient stage response, and that's understanding how you're going to put the fire out. Is it with an ABC fire extinguisher? Is that what's recommended? That may not be the case for your facility. You do need to have a good understanding of what batteries you have, what they contain, and how to control a fire if it was to occur. The ABC extinguishers handle kind of the ordinary combustibles that surround the battery, so they are going to work on your cables, your casings, your racks, but potentially not on the internal battery chemistry. So I think that's an important thing for people to remember. We're cooling the environment around the battery casing to kind of prevent it propagating, but we're not stopping the internal chemical reaction in a lot of instances. And then the next phase is that stranded energy threat, almost like a zombie risk. So, even if the external fire is out, the battery almost remains like a zombie hazard. The internal chemistry or that thermal runaway continues to generate heat and potentially volatile gases. It can reignite days later, as Michelle mentioned, months later, kind of without warning. And this is why in a lithium event, extinguished never really means stabilized. You need to be cautious and have procedures in place for these reoccurrences where something's going to off gas or it's going to reignite. And then the last point is really that continuous cooling, and that's almost a technical necessity when it comes to lithium batteries. You can't rely solely on visual cues. It's not as simple as you can't see any smoke or flame once the fire is knocked down. You being able to utilize or have access to thermal imaging cameras is really the only way to see inside the battery, see if the battery has stopped running, and you can test the temperature, making sure that the temperature continues to drop to ambient. And if it doesn't drop, then you know that the reaction is still active inside that battery and it's potentially going to move to adjacent cells. So having access to or working with your local fire resources to get thermal imaging cameras on site if there is a lithium battery event is really important. Kind of the critical safety protocol is almost like a 3-day rule, to loosely use a number. We want to make sure we're doing continuous monitoring. You need to treat it almost like a hot zone for a minimum of probably 3 days after the event to make sure that there aren't any delayed off-gassing kind of potential reignition with any of those batteries. And I'm just going to hand it off to JP to talk a little bit about some of the smaller scale fires.
Yeah, so this slide is really focusing on smaller scale. It's really emphasis on the small scale. There's 4 stages of fires. One is the incipient stage, which you can see is kind of highlighted by the green box. The second is a growth stage, and then followed by a developed and decay stage. We only really want, unless you're a truly trained emergency first responder with proper PPE and the right training, you should only really be fighting an incipient stage fire for your typical employee. And again, that typical employee also needs to be properly trained on how to use, let's say like a fire extinguisher. If you in your mind, you're thinking, I don't know what PASS stands for, and I don't know how to use a fire extinguisher, then you shouldn't be fighting the fire. You should be evacuating the area and calling emergency response early on. Just some things to always keep in mind when you're fighting a fire is that you should always maintain a clear egress pathway. You should never be fighting a fire if the fire is in between you and an exit, because that can quickly grow into an uncontrollable situation where a person might be trapped. Again, only trained personnel should be attempting to fight an incipient stage fire. And what is incipient stage? Well, per OSHA, it's actually defined as a fire which is in the initial or beginning stage that can be controlled by a single portable fire extinguisher or a standpipe fire sprinkler system or a simple hose system without the need for protective clothing or breathing apparatus. So this is really a small fire, something that you might envision when a cigarette butt goes into like a trash can, something along that size of a fire. A common theme for lithium battery safety overall is following manufacturer guidance or SDS guidance. Manufacturer guidance or SDS guidance can dictate which kind of extinguishment should be used. As Kristy mentioned, typically ABC dry chemical fire extinguishers are okay for lithium ion battery fires. It tends to attack those combustibles around the fire, but it may not necessarily extinguish and kind of terminate the fire completely. Because of thermal runaway, fires can lithium ion battery fires can tend to reignite. So dry chemical extinguishers can knock out the flames, but necessarily may not cool the cell. If safe, you're going to want to keep batteries cool with water, and when you're doing this, you want to be wearing respiratory protection as well. Also, like Kristy mentioned, you're going to want to keep in mind that to use thermal imaging devices to make sure that the batteries are staying around ambient temperature and you're not seeing spikes or rises following the event. And ideally, you're going to want to quarantine the affected batteries after cooling as well. Next slide. Okay, and so we just kind of drove home what to do in a small lithium-ion battery fire, but there may be first responders on this call that may be dealing with larger scale fires, and there are certain considerations that we want to keep in mind for them too. Understanding your pathways of exposure is really important. Of course, during any fire, the most obvious thing that comes to mind is smoke inhalation, and there are unique hazards presented for lithium-ion batteries. You have high potential for direct inhalation of hydrogen fluoride, volatile organic compounds, and airborne metals such as cobalt or nickel during long-term duration defensive suppression. After you're done fighting the fire kind of as a first responder, you also want to keep in mind decontamination of your turnout gear. Contaminated gear could and has been shown to off-gas certain compounds like halogenated hydrocarbons and toxic particulates inside of response vehicles. So it's really important to have good decon protocols to prevent inadvertent exposure after you think that you're away from the risk zone. Of course, you're going to want to have mandatory site exclusion and personal protective equipment. This is almost always going to be SCBA level respiratory protection, meaning that you have your own supplied clean air within the incident hot zone. Standard air purifier respiratory protection devices are typically insufficient, so you're going to want to have the highest level of respiratory protection when you're fighting these kinds of fires. And this, of course, requires a whole slew of considerations as well. If you're going to be donning SCBA level respiratory protection, you want to ensure that you have been medically tested to be able to wear those devices and fit tested from a certified individual to comply with certain regulatory requirements. And like I mentioned before, you want to have good decon protocols to ensure that you're washing down your turnout gear and you're leaving the hot zone without increasing risk afterwards to potential exposure. Go to the next slide. So there are several unique, potentially hazardous chemicals and particulates that are found in lithium-ion fires. From an IH perspective, it's important to keep these in mind, and kind of like Michelle mentioned, it's really dependent on the type of battery that you're dealing with and the kind of material that's around that battery as well. Typically, lithium-ion batteries have been shown to have smoke with hydrogen fluoride, hydrogen chloride, hydrogen cyanide, carbon monoxide, carbon dioxide, black carbon, and a whole slew of other kind of potentially hazardous chemicals and particulates. Visible smoke is the first indication that there is a respiratory hazard. And emergency response, like we just mentioned, should only be really handled by qualified professionals. IH monitoring may also be very useful when you're considering re-entry into an area that smoke has occupied. So let's say there is a lithium-ion battery fire in an office and it's been deemed safe by your emergency responders to reoccupy. You might want to take that with a grain of salt and ensure that you're doing some IH monitoring before. Practical IH screening could be for what's going on in the air. This could be for particulate matter, carbon dioxide, carbon monoxide. You may even want to consider things like lower explosive limits and VOC screenings as well. Like we've already kind of said several times, thermal imaging and observation after the fire stops is really key. And one thing that may not come to mind is kind of the surface contamination. The residual dust and debris that's left over could be contaminated. And this poses a dermal or an ingestion hazard for the occupants going to re-enter that space. Some of the surface contamination could contain dust and materials that have soot, metals, fluorides. So it's really important to have good cleaning protocols before you reoccupy a space. This could involve using HEPA vacuums, wet methods, and PPE.
Yeah, thanks, JP. So kind of going off that when we're talking about the industrial hygiene and the exposure, once the active fire is extinguished, that's when this remediation phase kind of begins, and you really can't manage what you don't measure. So we, in our involvement with both small scale to large scale lithium battery fires and issues, have deployed real-time telemetry, cloud-based kind of tracking, looking at particulates, so PM 2.5 and PM 10, to look at potentially during the active fire, what's in the smoke, is there particulate in there, what are the acid gases in the smoke, again combining that with maybe what's the LEL, what's the CO, really performing a comprehensive area assessment of the facility, of the environment, of the community. In addition to that, also looking at personal exposure sampling and focusing on, like everybody's mentioned, those heavy metals. So can you identify what was the makeup of the lithium battery that you're dealing with? Maybe what were the metals that formed part of that, and then can we sample for that? So we really want to be looking at the qualitative air sampling, characterizing those airborne concentrations, using telemetry. If it is a larger scale project, potentially the EPA will become involved, and they are a huge proponent of telemetry and getting that cloud-based platform, getting real-time monitoring data. So if you are on a project or you're an insurer and you're working with a client who has a larger storage facility, or maybe a set room where they have a significant number of batteries stored, working with them to make sure they have a really clear plan in place. If an incident was to occur, where are they going to source their telemetry from? Where are they going to get their units? What sensors are they going to have? From past experience, there's nothing worse than a fire happening. You're trying to obviously suppress the fire, and the EPA is there as well, suggesting that you get all this air monitoring as quickly as possible, and you have to, one, focus on getting the fire out, and two, focus on finding where these instruments are and how you get them on site as quickly as possible. So pre-planning for that really can save you a lot of time and hassle should an incident occur. And then once you're able to collect all of that information, being able to successfully do something with it, being able to do some statistical analysis and get a good understanding of what that data means, is really useful. It's a learning tool, not only for you, but for the industries as well, as we see more and more of these lithium battery fires, having a better understanding of what other people have done in response, what kind of levels of exposure they measured, and what controls they put in place is valuable information to share. Okay, so if we're moving into active telemetry, as I mentioned, this is one aspect that the EPA is a big proponent on. So if you do have a larger scale facility, they will ask you to implement active telemetry. The focus of that is for dust and particulate, setting up a remote enclosure, whether it's just at the entry to your building or on environmental kind of boundaries, to look at, again, particulate, what's in the dust, what's in the gas that's coming off the fire as it's actively burning, and potentially keeping those in place for days, weeks, months afterwards. The EPA will probably have some criteria that you need to abide by, but understanding the benefit of that information is really helpful as well. You can also, inside those units, set up multi-gas meters as well. So whilst you're monitoring for particulates, you can also monitor for some of those toxic acid gases that are associated with these fires: hydrogen fluoride, hydrogen cyanide, the combustible gases, carbon monoxide. Those units can collect data on a 30-second interval, on a 5-second interval, whatever you set them to. They can set triggers. Nobody wants to sit on a project for 24 hours watching a unit if a facility is on fire, but having the ability to go home and sleep and have an alarm trigger that comes to you is a really useful resource. And then also having the availability of gas detectors to be able to do spot measurements, if it's handheld electrochemical sensors for hydrogen. Maybe there's key areas in your facility. You're looking at waste storage bays after a fire. You're trying to actively remediate an area and you want to check for hydrogen at that time. If you have sealed drums that you're looking to dispose of off-site, once you've cleaned up after a lithium battery fire, being able to do kind of spot checks and having access to that equipment is really useful as well. Okay. And then when we're looking at the occupational exposure or the industrial hygiene type sampling, as we've mentioned, the focus really is on metals and particulates. So it's really a combination of what metals do you want to look for? Are you assessing for 15 metals, 16 metals? If you can identify what metals you're looking for, that is helpful. Otherwise, running a bit of a screen, personal exposure where the employee is wearing the sample pump while they're doing the remediation work is the best way to collect the data. If that's not possible, you can also do area monitoring and just get an understanding of maybe what's in the air, what's on surfaces. But looking at all of those metals, and some may be high, some may be low. You might be surprised as to what's in your batteries. In addition to that, also looking at just inhalable particulates. So that soot, as JP mentioned, settles on surfaces. It can have both PM 2.5 and PM 10 fractions. So understanding what the particulate levels are, if they're settled on surfaces and people are trying to clean it and they're aerating it, what's their exposure during that activity? And then also the toxic gases. Again, you can have personal monitors for any of the acid gases, hydrogen fluoride, hydrogen cyanide. And if this is a large scale cleanup, the EPA may have some oversight into that, as well as to some things that they require, in addition to things that you would do internally, looking at your federal OSHA or your Cal OSHA exposure limits. So once we did all of that, we also then looked at the statistical exposure, and we wanted to look at like the log normal Bayesian risk modeling. So in our instance, from some exposures that we have assessed, both from small scale to larger scale, we've had results that were really high for cobalt, fairly high for nickel, high for copper, low for zinc, low for lead. Some might be high for other exposures. Getting that information and being able to look at the number of samples you've collected, what that statistically means, how you can then control that work group. You know, if we used our Bayesian statistics on this data set here, it showed that from a 97 to 100% statistical certainty that this employer would be exceeding for poorly controlled exposure for cobalt and nickel. So in that instance, we know that that activity or that employer needs to wear a respirator, full face respirator with a protection factor of 50. If you have an understanding of what the potential exposure may be, before there's even a fire, you can have a plan in place that says, if there's a fire here, and if we are remediating it or cleaning it up ourselves, or the contractor that we bring in, they will be required to start the project with this level of protection, this Tyvek suit, this nitrile gloves. Having that written in place before an event occurs can really save you time when you get that contractor or your internal resources on site. They can start already, you know, in a good position. They're already being controlled. You monitor it and you make sure at that point you can either downgrade PPE if you need to, but starting with a higher level protection is always for the better. Whether you want to start in SCBA, in the, you know, the scuba, or if you want to start in the full face respirators. But again, like JP said, any use of respiratory protection, we need to be fit tested, trained, clean shaven. So having all of that part of your plan as well is essential if you are responding to this internally through your own organizations. Okay. Now, from our experience as well, any other exposures, you know, during, as Michelle mentioned, we've been on projects, you know, where a lithium battery, it's been 2 weeks later and it's just started to off gas, or a month later, even a year later, and it's just started to off gas during the removal remediation phase. So understanding that the risk doesn't go away once the fire is over, that it can continue is really important. You know, kind of mandating that respiratory protection, mandating full face respirators or SCBAs, depending on what you are doing internally. But having something in place if there is damaged cells and how you will handle them. Dermal protection, like JP mentioned. Now, are you wearing chemical resistant Tyvek suits? Are you wearing hard hats? Are you wearing nitrile gloves? Something to prevent that dermal contact from these heavy metals. They can be absorbed through the skin, so we want to protect against that as well. And then just your general cleanliness, you know, similar for any type of dust. We're not dry sweeping when we're doing this cleanup. We want to really suppress the dust and the soot as much as possible. If we can wet clean, if we can HEPA vacuum, you know, the use of water around lithium batteries can get tricky. So potentially you can't douse it in a significant amount of water, but maybe you can mist it and wet it down a little bit. But just understanding that the re-aerosolization of that dust, you know, can have a lot of heavy metals in it, and that can be one of the biggest exposure risks. And not only to your employees or the team doing the remediation, but if they're not controlling that dust in one room, the potential exposure for, you know, an office a few rooms away, depending on where your fire occurs, can also, you know, be something you need to consider. So I wanted to touch on this one quickly. As I mentioned, if you do have a larger scale fire, that the EPA will be involved. They do highly suggest and almost ensure that you have some type of perimeter or offsite community air monitoring. We really want to make sure that we're obviously protecting our community as well. And an easy way to do that is through these perimeter air monitors. You can use a particulate monitor or a dust track, positioning them either on all of your site boundaries or essentially upwind and downwind if you only have access to two. But implementing kind of these controls can help evaluate the air quality for offsite exposure for maybe the office building down the road, or the neighbor that might be concerned. If this is an event in a school and the residential neighborhood's concerned, having this type of data is really useful to show them that offsite exposure is minimal, if nothing. You can also look at inhalation type. We've done some inhalation case studies where we've assessed a neighboring office or a nearby building after a fire has occurred. They wanted to make sure that other workers weren't exposed in other areas. You can look at settled particulate, as well as airborne dust, airborne, some of those acid gases, volatiles, LELs, really showing if exposure is moving outside of the area where the burn occurred. And from our experience so far, there's been some peaks, but generally the average over the 24 hours, or the average exposure really to community and offsite, has been within the good range if we're looking at the AQI parameters. In addition to that, if you have a larger scale project and you're able to engineering controls, covering or tenting the area where the fire occurred, kind of reducing the amount of people that can get in and out, and reducing the exposure during that remediation decontamination phase is also great. If you're inside a building and it's just one area of a building that's burnt and the rest is still occupied by workers and personnel, you can restrict access to that area and shut it off, and then ensure that your ventilation for the rest of the building has sufficient MERV rating in your filters. Do you have boot washers or cleaning methods to stop people that have entered that area, tracking it out? What's your decontamination procedures just to stop the spread of potentially that soot and the toxic dust from entering other areas of your building? I'll hand it over to Mike now to give you some of the environmental aspects to think of as well.
Thank you. Okay, so we've talked a lot about the fires and all of the health and safety components surrounding those. So now is the aftermath. It's the what now. What are we going to do with all of this waste that has been generated as a result of these fires? So what I'll do is I'll go quickly over some general hazardous waste concepts that would apply specifically to this waste stream, cover a little bit about small scale incidents, large scale incidents, and then get into a little bit of the prevention side towards the end. So specifically with the hazardous waste regulations, a lot of us are used to being able to manage certain wastes, such as batteries, as universal waste. Once those batteries have been damaged, they no longer qualify for those regulatory relief exemptions under the universal waste rules. The reason being, the various hazardous constituents have been released from their matrix, right? So you're dealing with some very now complex assortment of various things that we've already touched upon. So then the question now becomes, okay, you're subject to the hazardous waste regulations. What do you do? One of the first things you need to do is understand what your waste is. That is the responsibility of the owner of the waste in the event of an incident like this. So getting into a little bit of what we call a hazardous waste determination, you're going to want to know specifically what we're dealing with. So is it what? Regardless of battery chemistry, you're going to be testing for some very specific things. The heavy metals that were mentioned, we would typically run a Chem 17 panel. That's the California Metals 17 that are regulated under the hazardous waste regulations to make sure you're above or below those thresholds. You have considerations. We mentioned the hydrofluoric acid and the different fluoride ions. Those can exist in residue, and they can also exist in firefighting media as well. California actually has a state code specifically for that, the California 131. And then from the hazardous waste regulations, there's also the reactivity. We discussed again the idea of stranded energy and reignition. So how are you going to safely transport these materials And so that assessment that Kristy spoke to regarding making sure that nothing in series is still reactive before transportation. So with the hazardous waste determination specifically, what are we doing? So we're essentially applying our knowledge of the hazardous waste regulations and merging that with the science. And we're making a formal determination on what is this waste. And what that does is that informs us on what we need to do to properly manage the waste, what we need to do to safely transport that waste, and ultimately what we need to do to dispose of that waste, and more specifically to destroy that waste. So really your best tools with these things are going to be a hazardous waste analysis plan or a hazardous waste management plan. Is going to dictate what you're doing in those situations, as well as the actual hazardous waste determination component. Okay, so a little bit about small scale. So these are the one-offs, right? You've got one battery that went off, phone, computer, scooter. You know, these we think of typically happening more at the household level. So I do just want to speak on them briefly. Everything remains the same regarding what I just spoke about. Something really important to mention is that household hazardous waste is regulated in California. So just because it happens at a house doesn't mean you're exempt from the regulation. What it means is that you need to go through the appropriate channels. So in the event that you're a household and you need to get rid of this waste, the best thing you can do is contact your local household hazardous waste facility, and they can advise you ideally on what they can and cannot do. If you're a business that already generates hazardous waste and has a hazardous waste permit, you just simply work with your hazardous waste vendor, and you get that off site. I wanted to mention, you know, though there are some people that may not already have a hazardous waste permit, maybe smaller businesses or even large businesses that don't routinely generate hazardous waste. What do you do? So I'm going to mention again in California that California does not recognize the federal EPA designation of a conditionally exempt or very small quantity generator. You're either small quantity generator or you're large quantity generator. And so what that means for those people that I'm speaking to is you are subject to the full regulations in this event. So the first thing you would do is contact the California Department of Toxic Substances Control if you're in California, and apply for what's called an emergency EPA ID number. Those can be issued the same day, and you then have a tracking number to begin working with a hauler to make waste determinations, get your waste on into transport, manifested, and ultimately disposed of. So we talked a little bit more about the large scale battery fires as well. So these are going to be those BESS systems, right? Again, everything remains the same with regard to the waste and the waste that we're dealing with. The difference is the size and complexity of it. Now we're not just talking about maybe just one scooter and a battery. We're talking about impacted vehicles, potentially impacted structures. So you now have a very complex mix of ash, in many cases, or char that you need to dispose of. So that goes back to my first slide, which is you're going to have to get back to your hazardous waste analysis plan and your hazardous waste determination pathway. That's going to be a document that justifies your decision in determining and saying that your waste is what you say it is, and that it's being properly managed, manifested, and disposed of. So again, with the, as was mentioned, with the large scale events, we do have the potential for stranded energy. when these are all in series. So that is something that we have to keep in mind. With the larger scale events, we could have environmental remediation if we have downwind effects, deposition of smoke, particulates, heavy metals. There may be more than just what's on site. We'll get a little bit into that in the next slide. And then just logistically, there's, you're dealing with a lot of different potentially agencies. You've got these high voltage modules that need to be shipped per DOT regulation. So those are some very specific requirements with regard to how you can safely do that, and frankly, how to safely get that onto a truck and ensure there's no reignition. So this slide is really just, an add-on to the large scale, just to give people a sense of what they could encounter should you have a large event that we just dealt with, that we just spoke about. You would have really multiple layers of different agencies involved. Of course, the business or business owner as well. So you may have federal EPA oversight. They may come in and take over the scene and have what's called an EPA administrative consent order, where they govern all of the things that we just talked about: continuous public monitoring, remediation timelines, so on and so forth. You also have regulations that come into play: TSCA, the Toxic Substances Control Act, and the Resource Conservation Recovery Act, which is the federal version of the hazardous waste regs. So they're going to all apply at these sites, right? So as I mentioned before, these wastes are no longer qualifying for exemption under the universal waste regs. And then you could have other state and local agencies. We have the CUPAs, who are the local hazmat regulators. They either sit in health departments, fire departments, or both, depending on where you are. As well, we have something called CERS, the California Environmental Reporting System, reporting requirements, which I'm going to get to in the next slide. Okay, so a little bit on prevention, and this is a little bit of a departure from waste, but we need to speak about this as well. So hazardous materials business plans. So what are they? So this is how we communicate to our first responders what hazardous materials we have where, in what quantity, and what we're doing to make sure that we do what's in our control to prevent these incidents. Okay, so by regulation, the California threshold is for, in the case of batteries, if you have 500 pounds of lithium ion batteries on site, then you are required by statute to submit to your local CUPA a hazardous materials business plan. So, a few EV batteries can weigh that much. It really just depends. So highly recommend that everyone take their inventories, particularly if you're a smaller business that may think that you might be on the cusp of qualifying or not, and making that determination as to whether or not you need this. So what is it? Ultimately, you're filing your online through the CERS system your hazardous materials inventory. And that is one thing, to just submit your inventory. But what's really important is we have to understand that we're also submitting a site plan. And so what we're submitting is something that first responders are receiving. And you may say that you have X amount, you may say that you have 10,000 pounds of batteries in this location. That's really important for first responders to know. If they're called out to a site and there's a fire, this affects their approach, right? So if they don't know that there's 10,000 pounds of lithium ion batteries, all of the different health and safety protocols that we discussed are a little bit more difficult to navigate, and keeping in mind that they're working in an emergency scenario, right? So the ability to give them this information ahead of time so that they can train on it, drill on it, get to know what's where within their jurisdictions. That's why this is a regulation. And so just to mention that emergency response with the hazardous materials business plan, There is a requirement to train your employees on this annually, and to make sure that everyone understands the contents of the plan. With that, I'll turn it back over.
Thanks, Michael. So a point that we just really want to drive home is that we want to be fire preventers. We don't want to be necessarily firefighters. A lot of the talk has been dealing with what do we do during fires, what do we do after fires, but ultimately, if we can prevent a fire from happening, that's the best case scenario, right? We want to eliminate the risk before it even becomes a hazard. So going back to kind of the common causes of lithium-ion battery fires, that could be physical damage, overcharging, or faulty charging, leaving batteries in extreme temperatures, improper storage or disposal. A lot of the common theme is that there's a human involvement in this. And, there's a statistic that has always stuck with me. Around 90% or more of wildfires are human caused. I wouldn't be surprised if we get a similar statistic with lithium-ion batteries as well, too. There's been an estimated 200,000 lithium-ion battery fires in structures since 2011, and I'm sure that number is probably underreported. So when possible, we really want to keep in mind safe charging and handling guidance. We should always be using an NRTL, a nationally recognized testing laboratory, pieces of equipment. Unless you're doing some kind of advanced electronic equipment development or research, you should be able to find these things off shelf. NRTLs include UL, Intertech, the Canadian Standards Association, FM. If you could see that stamp on the electronic, you know that it's been in some way safety tested. You should always be using manufacturer approved batteries, chargers, devices. These ensure that they're delivering the correct voltage, there's temperature monitoring involved, there's protective shutoffs potentially for the specific device that reduce overheating and the risk of thermal runaway. We should always be inspecting batteries before use, ensuring that they're rated for the intended use, and also we should be training our employees to identify the common causes of lithium battery issues. So this could be, to remove from service if it's swollen, if it's leaking, obviously if it's abnormally hot, discolored, odorous, generating smoke or making noises. And then if you do identify these issues with the battery, you want to remove it from service, place it into a fire-resistant container, and potentially, cover that with some kind of sand or other extinguishing agent. And then, kind of like Michael just previously said, you always want to ensure that you're disposing batteries following local regulations. Damaged batteries should not be going in normal waste streams. So again, like I've said a couple times, we should always be following the manufacturer guidance when it comes to storage, but there are some kind of basic considerations we want to keep in mind when we're storing loose batteries. This would be ensuring that they are in a dry, low humidity conditions out of direct sunlight. This would be in a climate controlled area, preferably with general ventilation in a room with sprinklers. If you can, you should segregate your batteries from common combustibles or other flammable chemicals or liquids. Look at what the manufacturer says in their instructions or in their manuals for long-term charging state. Some might say to stay at 30 or 50%. Some could be a little bit higher. You always want to protect terminals on your batteries from short circuiting. This would be, if there's damage or something to your terminals, you want to remove those. And you also want to develop site-specific limits. How much are you comfortable leaving in a certain room? Is that room fire rated? There's a bunch of different kind of things you should keep in mind in terms of how much you're allowed to store in a certain area. And NFPA is actually developing some guidance on this in their newest editions of documentation.
Perfect. Thanks, JP. So I know we're getting close to time, but just kind of to bring it all together, prevention is definitely the best strategy for all of this when it comes to lithium batteries, both from an environmental standpoint to an exposure standpoint. So just understanding some of the available guidance that's out there, those NFPA guidance, OSHA guidance, directing your own employees or your clients, if you're an insurer, towards understanding those standards and having a procedure in place involving, the fire department, getting them out to do a site walk, showing them exactly where everything is in your plan, really helps if there is a response needed. Understanding those safe storage guidelines is really important. Same things that JP just mentioned. And then really focusing on that operational readiness. Do you know your site? Do you know how you're going to respond? Do you know what your thresholds are going to be? And training, really setting these things in place, and then regular training, annual training on safe handling, on emergency isolation, on what your procedure is going to be if there is a fire event. The EPA has a really great document from their lithium ion battery task force. It came out in October last year, but it does focus on kind of the end game. It's talking about environmental recovery, which is really important and should be a focus. But we also want to think about our employees and our exposure as well. So we at FACT kind of use that guide to sometimes determine the thresholds for public safety, like community air monitoring, what triggers we should be using to align with the EPA guidance. And that can help you to navigate kind of that complex transition from extinguishing the fire to final site remediation and waste characterization. Essentially, the EPA document really can help guide you in protecting the surrounding community environment after that kind of hot initial phase of the incident is over. So looking at reviewing all those type of guidance can help you be prepared if an event was to occur. So kind of to summarize our core takeaways from today, battery fires, in particular, the larger scale ones, can be multi-phase events. You need to be concerned about that stranded energy. There is the risk of reignition, potentially long after the flames are out. Real-time monitoring, if the EPA is involved, definitely, but it's beneficial for you no matter what. So having something in place already to understand where you're going to source your monitors from, who you're going to work with if a fire was to occur, to get those resources out to you. Being able to collect enough information that you can do some statistics on it does help you to do some risk modeling, not only for the fire that occurred, but also anything potential that might occur at your facility. Helps also to justify your worker PPE levels, what type of protection they need from a respirator standpoint. If we're talking about post-fire, again, focusing on that universal waste status, what's requiring disposal, the strict SIRS reporting and the RCRA, kind of the waste tracking. So understanding that part of it as well, and adhering to all of your NFPA 855, conducting the annual employee training. That really is the single most effective strategy that we can provide you with here, is preparing for the fire that hopefully will never happen or come to your facility, but understanding what you will do if a fire was to occur. We have some sources here, and you'll see that on the webinar when it gets sent out to you. And then we just have, as you've probably heard throughout, FACTS has a lot of services and a lot of resources internally that we're able to assist with the pre-planning, or in the event of a fire, assist you with any of the services listed. Thank you.
Awesome. Thank you so much, Michael, Michelle, JP, and Kristy. We did get a pretty decent amount of questions here. And if it's okay with you four, I would like to go through some of them. And then depending on time, we can always follow up with the rest if we don't get to them all. So I'm going to kind of let you guys take over who wants to answer. But the first question we have is, what recommendations do you have to share about decontamination, PPE, and other equipment For teams responding to an EV fire, where can we find specific regulation/requirements pertaining to that specific issue?
In particular for electric vehicles?
It just said for, yeah, it just said for EV fires. It just said pertaining to PPE and equipment. I'm assuming that that would be correct.
Yeah, well, I mean, the whole world of lithium battery fire response is somewhat of a new and evolving thing. So there's different guidelines that are coming out all of the time. The EPA and their lithium battery task force has probably come out with the most documentation. It doesn't pertain exactly to EV, and it is definitely focused on a community type approach for a larger scale fire, but it does give you some indication on responding and some of the decontamination needed. Some of the fire response, the hazmat teams have also come out with some guidance for them from their perspective on how they're responding and the type of monitoring and PPE that they're wearing in their response. So I'm not sure if that would relate to this question as well, but it is definitely an evolving thing. If you have something in place and you want us to have a look over it as well and give you some suggestions from our perspective on how best to respond to that, putting a procedure in place for decontamination or what PPE is needed, we're more than happy to help with that as well.
Awesome, thank you. Next question is going to be, are all lithium-ion batteries labeled for easy recognition by first responders and consumers?
No.
No.
They are not, and it does, you know, as we all do, everybody loves an Amazon purchase, you know, depending on where your items are sourced from. You know, somebody might have great intentions of purchasing a piece of equipment through the right lines initially, and then they misplace their charger, as we all do, and they find a replacement charger on an Amazon or a Temu or some type of online. It could be anywhere actually, and potentially those are coming from a from a source where it's not as easily labeled, it's not identified, and we're not able to track that as easily.
Okay. Then the next one is going to be, what guidance do you have for storage of e-bikes, electric golf carts, and other electric vehicles? Can they be left outdoors? And can they, or should they be, or can they be parked indoors? They specifically said they are a community college in California, and they are used by students and other personnel.
Yeah, I think understanding like what your ambient conditions are going to be like, if it's going to be exposed for long periods of time in the sun, you know, and you're, let's say, in Las Vegas, where in the middle of the desert, and it can be, 100 degrees consecutively for weeks on end. That's something that personally I would suggest considering moving those, personal electrical vehicles inside. If it's short periods of time, 90 degrees, 85 degrees or less, I wouldn't envision there being a problem. But again, deferring to like manufacturer guidance and maybe putting the onus on the students to read their instructions or manuals that was provided by that EV device, and having them submit that kind of information to you could help provide a better judgment call too.
Okay, awesome. Thank you, JP.
Yeah.
And I think,
Go ahead, JP was, no, that's all right. I was just going to say, we, furthermore to what he's saying, 100%, it's whether you put the onus on the students or not, but we have dealt with facilities or campuses where a student has charged their scooter in their room and it has, there has been a fire because they haven't used the correct charger, or they've left it plugged in for 48 hours and it should have been discharged. So just understanding the behind the scenes, how somebody's going to charge it, where they're going to charge it, what the ventilation is like inside as well, whether you have a set room maybe on each floor where they charge them and it's not in their dorm rooms. I know states like New York, when it comes to e-scooters and e-bikes and that type of thing, they've almost put out a standard that regulates that you're not allowed to have them inside. You can't have them inside a building. They have to be charged outside. So we aren't at that level for California, but other states are looking at that as well. So
awesome. Well, thank you. It looks like just for time wise, we'll get one more in here. So they are asking what lithium ion battery chemistries are lower risk for fire and cascade?
like everybody else is going off mute. All right. No, for that question, it's hard to answer because I don't think there is a safe chemistry for any of them. Again, it's based on all those other aspects. It's based on how it's used, how it's stored. All of those things play a bigger role than the actual chemistry and composition. How well it's maintained, has it been, it could be the greatest battery ever, and then somebody goes out and they attach it to their leaf blower and they drop it and knock it around a bit, and then it has a few dents, and that impacts the dexterity of it, and it causes more issues. So the components internally don't play a big role in one that we would recommend above others.
Okay, awesome. Well, thank you, Kristy, and thank you everyone else for coming today. Anyone else's questions who weren't answered, we'll for sure follow up with you within 1 to 2 business days, along with the recording and the slide copy as well. Thank you again, and I hope everyone has a great rest of the day.